Hello, and welcome to PreCalc Lesson 7. Today we are talking about logic and how we can make valid arguments and how we can make invalid arguments. So the first thing that we're going to talk about is inductive and deductive reasoning. This is usually a topic for your science classes, but is really important. In this class, we are going to use deductive reasoning. First, we start with a major premise. So, a major premise could be so easy. It could be as simple as the sky is blue. Okay, so we go from a general case to something specific. That's our minor premise. And so I'll say, I looked at the sky today. What is a valid conclusion from this? Well, if the sky is always blue, which is not necessarily true, right? It could be rainy, it could be nighttime. But we are, in this class, for the purpose of this lesson, going to accept the major premise because we're evaluating whether or not the logic is correct. So I could say that the sky is purple. Even though that's not true, I can still evaluate whether or not the conclusions drawn from this are valid. And so instead of saying the conclusion is true or false, I'm going to say that it's valid or invalid based on the major premise or our general rule that says the sky is purple. Then my specific case, which is I looked at the sky today, and so my conclusion from the major premise and the minor premise is that I saw a purple sky. Now, in these problems, they're going to give you a major premise, a minor premise, and a conclusion, and you're going to have to tell me if it is valid or invalid, if you can draw that conclusion from the major and minor premise. Now, here's the basic idea. It is going to be valid if the major premise is more general and then the minor premise fits into that general rule. Let me give you an example of when this logic would be invalid. My major premise, the sky is purple. Minor premise, I saw something purple. And my conclusion, this is how they'll write it out for you, is that I saw the sky. Is that true? Well, again, we're not using true. Is that valid based on the major and minor premise? Actually, if I'm telling the truth, I saw this purple chair right here. Okay? I did not see the sky. This is invalid. Okay? The conclusion is invalid based on the information provided. Here's why. Instead of me describing something that fits into the major premise, so anytime I look at the sky, it is purple. Or if I see the sky, A, that implies that B is going to happen. So if I see the sky, it will be purple. I saw the sky, therefore it's purple. Here what I did, same idea. If I see the sky, we'll call that A, that implies that B must happen. Okay? But in this case, I said, oh, I see B. Therefore, A must happen. Right? I saw purple, therefore it must be the sky, which is invalid. Okay? It doesn't work. And we'll explain why it works. Sorry, I lost my eraser. Must have thrown it. We'll explain why it doesn't work in a moment. But let's get to the official problems and see if we can test them out. Okay, all normal dogs have 4 legs. You may have a dog with less or more legs. However, all normal dogs have 4 legs. That's our major premise. What is the condition? Well, if you have a dog, then you get 4 legs. Okay? If dog, then 4 legs. Now, that dog has 4 legs. Then, is it safe to say that that dog is normal? This is invalid. Why? Because my major premise, the general rule I'm working off of, says that if I have a normal dog, then it has 4 legs. But just because a dog has 4 legs does not mean it's a normal dog. The rule doesn't go backwards. Okay? And so this is invalid. Okay? I'm sure there are plenty of dogs with 4 legs that have other things that are abnormal about them. Okay? Let's look at another one. All boys are good. That child is good. So, that child is a boy. Is this valid or invalid? Take a moment and decide. You're right. It's invalid. Which is different than, never mind. I'm not going to make that joke. Okay. Why is this invalid? Again, we know that all boys, so if you have a boy, the boy is good. Biblically, that doesn't work, right? But again, we're just kind of accepting this and then seeing if it's drawing valid conclusions rather than testing whether or not the major premise is true or not. So we know that if you have a boy, for the purposes of this problem, then the boy is good. But I can't go from good to saying that it's a boy. It goes the wrong direction. So this is invalid. Now, how would this be valid if I changed it to that child is a boy? Then that child is good. That would be a valid argument because I know for the purposes of this problem that all boys are good. So if you have a boy, he is good. I have a boy. Well, I don't have a boy because I have no children. But that child is a boy. Therefore, that child is good. Okay? Boy implies good. If you have a boy, then it's good. We have a boy, so that boy is good. That is valid, logical thinking. Now, you will be asked to evaluate whether they're valid or invalid. What I would say for partial credit is for you to explain why. Otherwise, if you get it wrong, you lose all 5 points. So, explain why you think it's invalid or why you think it's valid, just like I've done today. The last part is that we are going to learn how to write some different logical statements. So let's take this statement here. All boys, well, you know what? We're not going to leave the girls out. All girls are good. If this is your original statement, I can also write an equivalent statement that looks like this. If not good, then you're not a girl. So since all girls are good, then if you're not good, then you are not a girl. That does work because I'm excluding all of the result, right? If you are not good at all, then you're not a girl because all girls are good. This is called the contrapositive. And these two are logically equivalent. So, if I said all boys are good, and I said that child is not good, then it is valid to say that that child is not a boy. Why? If there's a boy, then that boy is good. This one's not good, so it can't be a boy. So that would also be valid reasoning. Okay? Because the contrapositive and the original statement are logically equivalent. That means that they're saying the same thing. Okay? I'm going to move over a little bit. So, if my original statement is A implies B, or if A, then B is going to happen, the contrapositive says not B implies not A. So if not good, right, B was good, not good, then not girl. Okay? We also have two other statements, but these ones are usually not logically equivalent. So the first one. And so if we use them to draw a conclusion, generally our conclusion would be invalid. And that is the converse, not the shoes, and the inverse. So the converse says B implies A. Or if good, then girl. We already talked about how that's not necessarily a valid conclusion to draw from all girls are good. That doesn't mean that if I find a student who's good, that this statement guarantees that it's a girl. So we can write the converse of the statement, but it's not necessarily valid. Okay, the inverse is simply taking the opposite of these. So not A implies not B. So if I were to write that out, if not a girl, then not good. And this marker is dying. Goodbye. It didn't make it in. So that's how we would write the inverse. Not A implies not B. So if you're not a girl, then you're not good. This is not the same as that. It's not saying the same thing, so we have to watch out for that in your conclusions to make sure you are not including the converse or the inverse as valid arguments. And that is problem set 7.